Hello everyone, my name is Rukuto Kamo from Childline, Kohima. We are so grateful to the Department of School Education, Government of Nagaland for giving us a slot to introduce Childline to you through this medium. What or who is Childline? Childline 1098 is a national toll-free helpline number for children in distress and in need of care and protection, which operates 24/7. It is a project under the Ministry of Women and Child Development, Government of India. Childline is currently operating in 570 cities all across India and presently operating in 5 districts in Nagaland, that is Kohima, Dimapur, Mokokchung, Peren and Kiferi. Who can call 1098? A child or any concerned adult can call 1098 anytime for children in distress and in need of care and protection. Childline do not reveal the identity of the person calling 1098. It is always kept confidential. What are the categories of cases supported by Childline? There are the missing children, the runaway children, abused children, children seeking medical assistance, child labor, street children, and all kinds of children in need of care and protection. What are some of the services extended to children by Childline? We respond to phone call 24/7, rescue of a child if need arise, nutrition and emotional support and guidance through counseling, referral services such as medical assistance, temporary shelter, education sponsorship, restoration and repatriation of a child to their families in the best interest of the child. How do we create awareness? We conduct awareness programs in college, schools, churches, colonies, outreach programs through one-to-one interaction, small group meetings, and distribution of our Childline IEC materials. We also create awareness on the existence of Childline and its services and the different laws of our country protecting our children. We also create awareness on the cases prevalent in our city. Childline does not work alone or in isolation. We work along with various line government departments and agencies like the district administration, the police department, the legal department, education department, medical department, labor department, the social welfare department, state child protection society, district child protection unit, the child welfare committee, our Childline partners in different parts of the country, and all the NGOs working for children. In conclusion, we want to send a message across to everyone that even as the entire world and our nation is battling against COVID-19 pandemic, Childline is still there to reach out to any child in distress and in need of care and protection. We also take this opportunity to make an appeal to each and everyone to please call 1098 whenever you see any child in distress and in need of care and protection. Let us all join hands to make our city a safe place for our children to live in. Thank you, God bless, and stay safe.
Hello everyone and welcome back to the class of Algebraic expression and identities, where we'll be dealing with exercises now. In the previous videos we have learned about multiplication of monomial and monomial, monomial and binomials, binomials and binomials, and so on. Now we're going to put that into practice now. So let us turn to exercise number 9.3. So we may not be able to cover up the whole exercise, but we will try our best to cover up a few of the methods that will be applied here. So let's start with the first question. Question number 1. Carry out the multiplication of the expressions in each of the following pairs. So, question number 1. The first question is 4p, q plus r. So here we see two terms, 4p and q plus r. Now, if you look at the question, you can understand that 4p is a monomial, whereas q plus r is a binomial because it has two terms. So we simply have to multiply these two expressions. So we will write it as equal to 4p into q plus r. Now the first step of multiplying a monomial and a binomial is you take the first monomial and multiply it with the first term in the binomial. So that step will be written like this, 4p into q. So this is your first step, 4p into q. Next step will be 4p into r. 4p into r. But before we go there, please make sure that you write the plus sign. Plus 4p into r. So after that, it is simple multiplication. 4p into q, you will not be able to multiply anything, so you're going to write them all together. So it will come as 4pq plus 4pr. So the product doesn't matter that much here. What we have to understand here is the step that we have followed. So if you understand this particular step, you will be able to apply it in all the questions in the other questions that are given in the textbook. So let's give another try with this third question. The third question is a plus b, comma 7a to the power 2, b to the power 2. So this is the same as the first question. The only thing here is monomial is now in the second place, binomial is in the first place. Alright? So we'll write it like this, a plus b into 7a square b square. Now, when you multiply two terms, it doesn't matter if you change the position. A plus b can go at the back, it can be in front also. So we will rearrange them. 7a square b square into a plus b. So this arrangement is done for better understanding so that we can relate with the previous question. Now it is same thing again. The first term, a monomial, you multiply with the first term, 7a square b square into a. After that, there is a plus sign after a, so you write plus. Then you take 7a square b square and multiply with b. A square b square into b. Now in this question, you can see that these two are being multiplied plus these two are being multiplied. Alright? So you will multiply these two first. 7 will remain as it is. A you have 2 times over here, A you have 1s over here. So when you add these two, you get A to the power 3. That is 2 plus 1, 3. There's no B, so B will remain as it is, B square. Plus, in the next question, 7 will remain as it is. A, there's no A in the other term, so it will be A square. Here we can see B square and 1B. That means 2 plus 1 is 3. So you will write B to the power 3. So this is the simple multiplication of a monomial and a binomial. All right. So we'll move to the next question. In the next question, we will be dealing with monomial, and binomial. So let's look at the first question. Question number 3. 3.1. The question is a square into 2a to the power 22 into 4a to the power 26. So here we can see monomial, 3 monomials. So this is simple multiplication. We have already learned about the coefficients of the terms. So if you look at the first term, a square, there's no number given here. That means there is a 1. So you will multiply 1, okay? You will try to separate all the numbers. So 1, here in the second term, the coefficient is 2. So you will write 1 into 2, again into. In the third term, the coefficient is 4. So here you have separated the numbers, 1 into 2 into 4. Now what is remaining? A square into a to the power 22 into a to the power 26. So I hope this is clear. The numerical terms have been separated, right? And the variables have been taken together, okay? So 1 into 2 into 4 is 8 into. Now if you look here, you have 2 A's, 22 A's, 26 A's. Simply add all the powers. That means 26 plus 22 plus 2. So when you add them, you get 0, 5. So you are getting a total of 50. That means there are 50 A's here. A to the power 50. So this can be written as 8a to the power 50. So this is your final answer. Alright, this is a simple multiplication. The only thing we did here was separate the numerical factors first and keep the variables together. Alright, so that your multiplication will be easier. Now let's look at the next question. Question number 2. It is given 2 by 3xy into minus 9 by 10 x to the power 2 y to the power 2. So you have to multiply these two terms. Here also it's a monomial into monomial. Alright, do not get confused because of the variables xy. They are not separated, they are together. So this is one term, this is one term. Alright, so let's do it in the same process. Take the numbers first. Here the coefficient is 2 by 3. So I write 2 by 3 into minus 9 by 10. So I have separated the numbers. Now I will take the variables together into xy into x square y square. This and this are together. Alright? So now let's, before we continue with the multiplication, we can cancel the terms. The numerator, in the numerator there is 2. So 2 into 1 is 2. 2 into 5 is 10. This is how we will cancel out. And here we have 3 into 1 is 3. 3 into 3 is 9. So this is how you will cancel. The remaining numbers you multiply. 1 into minus 3 is minus 3. 1 into 5 is 5. And if you look at the second multiplication, first you check x. There's one x here. There are two x here. So if you add them, you get 3x. 1 plus 2 is 3. Similarly for y, there's one y here, there's two y's here. So when you add them, you get 3 y's. That means y to the power 3. So this can be written simply like this. Minus 3 by 5 x to the power 3 y to the power 3. Or you can keep it here also. All right, this will also suffice, but just for a better understanding, I have written this down. All right. So that is all about multiplying monomials. Let's move on to the next question. Question number 4. Question number 4. Let's do the first one, A. Now, here it reads, simplify 3x into 4x minus 5 plus 3 and find its values for question 1, x is equal to 3, question 2, x is equal to 1 by 2. All right. So first we will simplify this equation, this expression. So the first step will be to, if you look at this question, you can see a monomial and a binomial. So as we did in the previous questions, we will multiply 3x into 4x, these two. Then there's a minus, again 3x into 5. And don't forget the plus 3. All right. So now after this, it's a simple multiplication. Multiply the numbers first. 3 into 4 is 12. 2x, so that means x to the power 2 minus 3 into 5 is 15. And there's only one x, so keep the x as it is, and plus 3. Now, when the question states simplify, it means making it simple, right? So after solving all this, we have made the equation simple. Now we can apply the questions here. In the first case that they have given us, x is equal to 3. Now when they are asking us to put x is equal to 3, that means in place of all the x here, we will be using 3 now, right? Instead of x, we will use 3, okay? So when we put x is equal to 3, this equation will become 12 into, now in place of x, we will put 3 to the power 2 minus 15 into, in place of x, we will put 3 plus 3. So it will become 12 into 3 to the power 2 means 3 multiplied 2 times. That means 3 into 3 is 9 minus, let's keep this as it is, 15 into 3 plus 3. So when you multiply 12 into 9, you get 9 to 18, 919. So you are getting 9 into 1 is 9 plus 1, 10. So when you multiply 12 into 9, you are getting 108. And if you multiply 15 into 3, 3 into 5 is 15, 3 into 1 is 3, plus 1, 4. So you're getting 45 plus 3. So after this, you subtract these two first. Let's subtract them. 108 minus 45. If you subtract 8 minus 5, you get 3. 0 minus 4 is not possible. So you will borrow 1. Borrow 1 from this one. This one will become 0 now. This 0 will become 10. Okay. So you know this, so I do not need to explain much further. 10 minus 4 is 6. So you're getting 63. And don't forget your plus 3. So your final answer is 66. Alright. This is the first part. In the second part of the question, I will leave it for you to attempt. In place of x, you will put 1 by 2. Now I will give you the general form how it will come. 12 into, in place of x square, I will put 1 by 2 the whole square. Minus, in place of 15, I will put 1 by 2 and plus 3. Now you simply have to make this square. 1 by 2 square means 1 square by 2 square. Alright, you can write this as 1 square by 2 square, which will give you 1 by 4. Alright, and in that manner you can calculate and a final answer, you will get a numerical answer in this manner. All right. So this question I will leave for you to attempt. Let's go to question number 5A. It says add, and they have given us these numbers, these expressions: p into p minus q, comma, q into q minus r, and r into r minus p. So before we add them, we will simplify them one by one. P into p minus q, we will simplify this now. Monomial into binomial. So p into p, this 2, minus p into q. Now in exam, you don't have to put these arrows, okay? This is just for your understanding. Now, p into p is nothing but p to the power 2 minus p into q is pq. Similarly, for the next part, q into q minus r is q into q minus q into r. So when you multiply q 2 times, you get q to the power 2 minus q into r, you simply write it as qr. And for the last term, r into r minus p is equal to, now when you multiply this, you will get r into r minus, again, r into p. So finally you will get r 2 times, you multiply, you get r to the power 2 minus rp. Now we will be adding these 3 expressions. So as I explained earlier in the previous class, it's not necessary that you write down in columns exactly where, like this. You need not write it like this, because p, q, r are different terms. You have to separate them now. So what we're going to do is, I'm going to write the first expression, p square minus pq. Now, in the next expression, you can see that it starts with q square. There's no q square here, so I'll write it somewhere around here. Q square minus qr. And in the third expression also, you can see that there's no r square, so r square minus rp. So all of these you add, you get rp minus r square plus qr minus q square plus minus pq and p square. So this is your final answer. You can arrange them in this manner: p square plus q square plus r square, and then minus pq minus qr minus rp. So this is your final answer, and this is how you will simplify expressions and add, or in other instances you will be subtracting them. All right? So this is all about multiplying monomials and monomials, monomials and binomials, and simplifying the monomial and binomial in this form and adding. And other questions you'll see subtracting. All right? In subtracting, for instance, since due to time constraint, I will not be able to solve problems, so too many problems. So I'll show you an example of how subtraction takes place. If you put minus here, in the last expression, this will become a plus. All right? If there are other numbers here, for example, if there's a QR over here with a minus, if you are subtracting, this minus will become plus. And in other cases, if there's a plus here, when you are subtracting, this plus will become minus. Okay? And the necessary procedure, you will be able to understand that if there are 2 minus, it will become a minus. If there are 1 minus and 1 plus, you have to subtract. All right? So on and so forth. So this is all about subtraction and addition of algebraic expressions by simplifying these particular expressions. All right? So in the next class, we'll be learning more about multiplication of expressions. So I look forward to meeting you again. So till then, keep practicing. We will meet again very soon. Thank you.